Hello, welcome to this Friday session of BIM College. This is our last day of this iteration of BIM College, and we will have several sessions, and we're closing with a bang. For our first talk of the day, we have Svetak Sundar. Svetak is a technical solutions engineer at Google, specialized in data flow, and he will be presenting. Actually, he will be showing us a deep dive into the data flow architecture. So please, thanks for being here, Svetak, and you can start.
Sure. So, good afternoon, good morning, good evening, wherever you are in the world. I'm Svetak, and I'm a solutions engineer at Google, and I work closely with Dataflow. And I'll be specifically deep diving into the GCP Dataflow architecture. And so, this is the first of many sessions today, and I want this sort of to be the foundational building block of what carries you on for the rest of the day. The rest of the day will be a little more deeper dives into some of the topics that we touch on in this talk. So I have three goals of this talk. So first, I want to cover the Dataflow Runner architecture. Additionally, I want to touch on some core features that GCP has introduced into the Dataflow Runner to make running your Beam pipelines more seamless. And finally, I want to talk about some horizontal integrations, that your Beam pipelines can work with other parts of GCP to make, again, running your Beam pipelines as simple as possible. Awesome. So Dataflow is a managed service by Google Cloud. And first, I want to touch on sort of four key aspects of Cloud Dataflow. So there's graph optimization, there's monitoring, there's logging, and then there's also resource autoscaling that's sort of a recurrent theme throughout. So I'll try to touch on that as well, throughout this talk. So to start with graph optimization, a lot of it, sometimes you have optimizations with how you're running your pipeline. So you can have maybe a consumer producer, fusion, for example, or a sibling fusion. And I don't want to get too detailed into these, but you can sort of think of graph optimization sort of like compiler optimization. So it's going to be optimized to help you run your Beam pipelines with minimal resources and as timely as possible. So the next thing Cloud Dataflow has to offer is the actual UI itself. And so you can navigate to this, via the Pantheon UI, and you can click on a Dataflow job ID that represents one of your Beam pipelines running. And the first thing you'll see is actually the steps of your Beam pipeline. So you'll have your source all the way to your sink and everything in between. You can also see some job metrics if you click on another tab in that UI, and you can see some key metrics here, such as CPU utilization and memory usage, for example, memory consumption. And on the right pane, you can see some other key metrics, for example, some key metrics about your steps. So if you were to actually click on a step on the right pane, it would show what the wall time of that step might be, or what the throughput might be of that step. And as you scroll down, you can also see some things such as some experiments you've passed into your Beam pipeline. And finally, on the bottom, you can see that there's a little preview of logging. And so, if we expand this out, logging is actually going to be our centralized repository of where we keep track of what happened in our Beam pipeline. And so, logging will contain things from your info level logs all the way up to like maybe your error level logs. And this shows sort of anything and everything that's happening in your pipeline. And so oftentimes when there might be an issue in your pipeline, logging is the first place we go to see what might have happened during this time. And yeah, it shows basically a bunch of information about your workers that are executing this Dataflow job, and workers are essentially just these compute engine VMs. Cool. So next, I want to get into some integrations with other GCP services. And in specific, I want to cover integrations with Cloud IAM, Compute Engine, and Cloud Networking. So at a very high level, what happens first is you have your Beam pipeline that you've written out, and you're going to submit this to what we call a regional endpoint. And a regional endpoint you can think of as your primary worker. So this is going to be the worker that's not executing the work, but it's sort of resource provisioning and understanding what needs to be done to actually execute your job. At the same time, this pipeline code is going to be sent to GCS and Google Cloud Storage. And Google Cloud Storage is going to hold common resources that the workers actually executing your work will need to access. And so once you have submitted this to your regional endpoint, or also known as your primary worker, is going to lease out work to your secondary workers. And your secondary workers are going to be the ones that are actually doing the work. And so these secondary workers, like I just mentioned in the previous slide, are all compute engine VMs. Great. So we have our regional endpoint and we have zones. So a little bit of terminology here. So regional endpoints, you can think of this as what we just mentioned to the primary worker. So it maps to the primary worker in the sense that it doesn't actually do the work for you, but it actually provisions the work. And so, the region is set to US Central 1 by default, but you can override this. And then your zone is going to correspond to your secondary data flow workers, which are going to be the compute engine VMs actually carrying out the work. And so this is going to define, the zone is going to define the location of the data flow workers, and it's going to default to a zone based in the region selected. But of course, you might not want this for various reasons, such as the ones that are listed on the slide. For example, data locality or geographic separation. But just do keep in mind that if your primary worker is in one region and your secondary workers are sort of in a zone outside of that region, there could be some delay just based on network latency. So with Dataflow in Cloud IAM, there's minimum of two service accounts that need to be provisioned to successfully execute a job. And you can think of these also as sort of just mapping to that primary worker and the secondary workers. So for example, you have your Dataflow service account, and this is going to be mapping to your primary worker. So this is going to be used for worker creation, monitoring, etc. And then you have your controller service account, which is going to map to the secondary workers that are actually carrying out the work. So this is going to, give you this is going to provision you to access resources that you might need for your pipeline. For example, files from that GCS bucket that was shown on a few slides before. And oftentimes, sort of as a side note, we do see a lot of people that use Dataflow either don't give these service accounts the right permissions, or sometimes they're not completely in understanding of why that two service accounts are even needed in the first place. Great. So now I'm going to talk about some newer features that we've introduced in Cloud Dataflow recently. So in distributed data processing, there's this common problem of a hotkey issue. And you can think of this as essentially your primary worker is going to lease out work to these secondary workers to actually do your job. And sometimes, the primary worker will assign a lot of work to one secondary worker and not enough work to the other secondary workers. And this is going to cause sort of an imbalance, and this is going to delay the parallelization process, which is actually going to hinder your job performance. So this is called as the hotkey issue, or this is called a sharding sometimes. So what we've done is we've actually introduced a feature called batch dynamic work distribution that's going to actually just redistribute the hotkeys for a better workload distribution. And this is all fully automated on our end. So another feature we have is the Dataflow shuffle service for batch jobs. So you can consider a pipeline running where you have your steps from your sources to your sink, and you have your source, and perhaps you have a resource intensive step such as group by or co-group by. This is going to be when it gets to this point, it's going to send that over to the shuffle service. The shuffle service is going to make the computation, and it's going to send it back to your Dataflow pipeline, and your Dataflow pipeline will continue as normal. And analogously, we have something for the Dataflow streaming engine. So the streaming engine, same idea here. You have your Dataflow pipeline running. You may have some resource-intensive steps that you want to send to the streaming engine. Streaming engine is going to take care of the computation, send it back to your Dataflow pipeline, and your pipeline is going to keep progressing. And yeah, this is really helping out three key things. So auto scaling for one, just based on your worker resources, right? You can provision out less worker resources. This does provide smoother auto scaling. So another thing we have is our Dataflow SQL UI. And so you can think of this as Beam SQL essentially. So you can write SQL code to trigger a Dataflow job. And this is really nice because this doesn't require you to have an extensive Java background or a Python background to trigger a job. You can simply do it via SQL. And yeah, so Dataflow SQL is essentially the same as Beam SQL. And for example, if you're using GCP, you might run this on BigQuery, for example, which is our analytical warehouse. So another feature we have is flexible resource scheduling. And so to get into a little bit of background, we have our standard VMs, but we also have what we call preemptible VMs, which are for sort of short-lived time on the VM. So the VMs can shut down after, say, a period of 24 hours. They're ephemeral, essentially. So the idea is that we have a combination of these standard VMs and these preemptible VMs to run your job. And so even if the preemptible VMs go down, there's other VMs that are sort of still working on the job. And this is pretty useful just from a resource management standpoint. You'll eventually the bills will kind of come down because your standard VMs, you won't have standard VMs just sort of running all the time. Another thing we have is Dataflow templates. And so this is really useful, first of all, because it doesn't require coding. So this makes it accessible to many more people. Another key thing here is that you don't have to recompile your code every time you want to run your job. So you can select one of 20 plus Google provided templates, or you can create your own. You have popular ETL sources and sinks. You can run this on both streaming and batch jobs. And yeah, the key here is that you don't have to recompile this every time you want to run your job. And this is useful because you don't have to have your dev environment, or all the dependencies sort of set up to actually compile that code. This can run standalone. Great. So I've talked about sort of some architecture from Dataflow, introduced some things like DAG optimization, and also some key features that we've introduced recently, such as the templates, the SQL UI, streaming engine, and shuffle service. And of course, we have monitoring and logging, which is sort of our centralized repository when we want to sort of troubleshoot our pipeline or just understanding what's gone on. So I think with that, we can go to any questions.
Okay, sorry, I was muted. Okay, let's see if we have any questions. We have, give us a minute to see if we grab any questions from the audience.
Sure. And can I stop the present mode here?
Yes, so that you can go back to that to see us.
Yeah.
Okay. Now, everybody remember that this material is available in the GitHub repository that we have made available for you. And Svetak, I don't see you are in the Slack for Beam College, but hopefully I'll send you the link so that you can register later.
Okay.
So that in case that somebody has a question later, they can send you a message.
Yeah.
They can tag you in the Slack, okay?
That'll be great.
Because looks like we don't have any questions. So well, thank you so much, Svetak, and thanks for your time. And remember, everybody, we will be the materials are published, and this is available in our YouTube channel so that you can share with your peers. Thank you, and have a good rest of the day, Svetak.
Awesome. Thank you.
Bye.
Hi, welcome to Beam College. My name is Alma Maria Renaz, and I will be your moderator today. This session is monitoring, and our teacher is Jeremy Gomez. And just some housekeeping reminders before we continue on to this session that Jeremy is going to teach us about monitoring. Please remember to fill out the survey and feedback form, and we will be taking questions and answers at the end of Jeremy's presentation. We will be taking those either from Slack or from the YouTube comments. So Jeremy is going to be Jeremy, who is a cloud consultant at Google, has more than 10 years of professional experience as a software developer, data engineer, and consultant. So Jeremy is going to be teaching us today about monitoring. Thanks, Jeremy.
Thank you very much, Alma. Hi, everybody. So I hope you're all doing good and you've been enjoying the Beams session so far. And today I'm going to tell you about monitoring. So really monitoring is about all the metrics that are available to you in Dataflow so that you can understand more how your job is performing and also to be alerted if anything goes wrong with your job. So I'm going to present you a few slides talking about metrics for like 10 minutes, and then I'll switch to a demo showing you a job that I've created to show you how you might be using these metrics. Okay, so you can think of metrics in Dataflow in broadly 4 types. What I call the native metrics, which are really metrics about your job. Then the worker metrics, which are the metrics that are about your workers that are running your jobs. Then you have something more, which is called monitoring agent metrics. And then at the end, you have things called custom metrics. Now, I will show each of them to you. And pretty much all these metrics show up in what we call cloud monitoring. And cloud monitoring is the product on the Google Cloud Platform that enables you to see and handle metrics and alerts. But also the most important metrics for your jobs, you're going to see them in the Dataflow UI. So during the presentation, I will show you the 2 UIs, the cloud monitoring and the Dataflow UI. So let's look at the native metrics first. So frequently used ones include is my job failed? So it's called is failed. So you'll see that all these metrics start with dataflow.googleapis.com/job. Another very important one is the system lag. I'll show you what it is later. But it's basically the latency of your pipeline. You have per stage system lag if you'd like to have more more precise information. You also have the current number of vCPUs. This is really useful to know if your job has auto-scaled or not, how many CPUs it's currently using. Then you have things about the element count or element produced. This is really how many elements are going through your P collections. So for example, you could see maybe that a certain transform has 50,000 K elements per second. Some metrics then are influenced by time. These metrics are a little bit less easy to alert on because they're basically multiplied by all the time, but it's still useful for monitoring your costs, for instance, because the memory time that you're having, the vCPU time that you're having directly correlate to the cost that you're paying for your pipeline. You have some additional metrics if you are using PubSub. So PubSub is our messaging system on GCP. And if you're reading or writing from PubSub, you're going to have access to these metrics, for example, the read latencies or the write latencies. And finally, you have some additional metrics that are transversal to GCP. For example, the logging metrics. And the logging metrics will tell you if your pipeline is logging a lot. And this is quite important because if you're logging too much and you're not aware of it, you might actually have some performance problem with your job, and also your cost might go higher because logging is usually not free. So these are native metrics, very important, the most important. Then you have your worker metrics. You want to know how your different machines are behaving. And you will see that they start with compute.googleapis.com. And they're all about the machines that run your job. So for example, you could go and see the CPU utilization. You could see information about your disk I/O. Are you writing a lot to disk or not? You could see information about the RAM, the memory that you're using, only for the family E2 of machines, however. Then there's something, it's also transversal to GCP, which is called monitoring agent metrics. The monitoring agent is a little agent that you can install, and it will give you more metrics about your workers. In Dataflow, it's pretty easy to enable it. You just pass this flag here, enable Stackdriver agent metrics, and you will be able to see them. However, the metrics that I told you about before are free, but these ones are not. And with these agent metrics, you could have a look at CPU utilization, also disk I/O also, and you could have access to your memory, even if your machine is not E2. So this might come in handy. And finally, the custom metrics. The custom metrics are metrics that you would define yourself in your own Beam code. In Dataflow, you have two types of custom metrics. The counters, which are metrics that can be incremented and decremented, and distributions, which are metric that you would update with new values, and at the end, well, at any time, it would give you statistics about your distribution, like min, max, and average. And here's an example of how you would create your metric and increment your metric inside the process element method of your pipeline. So it's basically just doing inc.inc to increment. And so you will be able to see these metrics in Cloud Monitoring and on the Dataflow UI. So remember, native metrics, worker metrics, agent metrics, and custom metrics. Of course, the native metrics are the most important, but with the others, you can have access to more information about your job. Okay, let's have a look at the common use cases, and let's see what metrics we would use. So has my job failed? You would use the native metrics is failed, and you would have a look and see if it's more than 0. However, this is only useful for batch pipelines, because for streaming pipelines, your job kind of actually never fails. If something it doesn't work, it will retry forever. So this only works for batch jobs. Is there any lag? Meaning, is my pipeline being slow? And here you would use the native metric system lag, and you could filter only to see your job name or your job ID, or the per stage system lag, which will give you information about the lag for each stage of your pipeline. Then, is there a spike in processing on my pipeline? For this, you could look at the native metrics num vCPUs. So it will tell you if your job has upscaled or downscaled. Another useful thing is to look at the elements count and elements produced count, which is really the throughput. You could look at the throughput for one of your first P collections, maybe the one that is reading from the source. So let's say I'm reading from PubSub. If I look at the throughput of this P collection, it will tell me if more messages than usual are actually being read by my pipeline. Is data processed fresh or old? So in this case, you would use the data watermark age or the per stage data watermark age. It's basically AKA data freshness. It's the same. What is my CPU utilization? So in this case, you could use the worker metric, CPU utilization, or you could use the agent metric if you installed it. Is my memory close to full? You have the native metric, total memory usage time, but it's not easy to alert on because, as I said, it increases with time. So you would rather use, if you're using an E2 machine, you could use the worker RAM used metric, or you could use the agent metrics. The last one I would talk about is a dependency failing? So let's say usually you have external dependencies in the job. Let's say you're using a cache like Redis on memory store, for instance. The first thing you could do is just use metrics that are not Dataflow metrics. Use metrics that are specialized for your dependency, like Memory Store has lots of metrics that you can use. But there are also other solutions. You could use a custom metric. So in your code, every time you connect to your dependency, if it fails, you could increment a counter, and you could easily alert on that. Or the last solution would be to create what we call a log-based metric. And I think Meran on the next session, so stay with us, we'll tell you more about this. So in your Beam job, you can actually log things. So you could log, could not connect to my dependency, for instance. And based on this log, you can create a metric. It's called log-based metric. And then you can alert on that. And to finish, it's very important to set up alerts. When you set up alerts, you do two things. You choose your policy. So, for example, the mean data freshness has been above 10 minutes for 2 minutes. If this is the case, then please alert me. Then you choose a policy trigger, like all conditions are met, any condition are met. And then you choose your notification channel. So it can be email, Slack, webhooks, and it can also be PubSub. Your alerts can be sent to PubSub, and you usually use that if you want to integrate with other systems like GCP components or third-party systems. And in this case, your third-party systems or GCP components will come and read from PubSub. So it's useful if you have an on-premise alerting system, for instance. Okay, so I'll show you both on the cloud monitoring and the Dataflow UI what you can do. It's just an introduction, of course, but it'll be useful. For this, I've created a job, a Dataflow job, actually 2 Dataflow jobs. One on the left that generates some measures. So you could imagine a factory, some robots in a factory that are creating cars, for instance. And they are sending messages, and in my case, messages about the pressure of the machines. So I write this to PubSub, and then I have another job that I will show you, and this is the one I'll be using, that processes these measures. And if the measures are good, write it to PubSub, and if they're bad, they're going to be writing the averages of the pressure into BigQuery. So let's have a look at the console. So this is my console for Dataflow. And you can see here that these are my jobs that generate messages. I have 2 instances, and then this is the processing job. So I will click here. So first you have the job graph, and here you can see what I'm doing. I'm reading from PubSub, I'm windowing. So this is not a perfect pipeline. It's not a very optimized pipeline on purpose, but it could be a real life pipeline. So I'm reading from PubSub, windowing, converting to objects, and here I'm filtering. If the events are bad, they're going to go to a PubSub topic. If the events are good, I'm going to group them by key, the key being the factory, and I'm going to compute the mean every 5 seconds, the mean of the pressure. And then I will write this to BigQuery. So talking about metrics, I'll go to the job metrics here. But before I do that, I will just go to cloud monitoring before. So if I go to the navigation menu here and go to monitoring, I will open cloud monitoring. So I've already opened it for you here. And you have multiple features here. The metric explorer is interesting to explore some metrics, but then the dashboards are very important to see lots of metrics together. And the alerting is very important, of course, to alert on your different metrics. So what I'll do here is that I'll show you one metric per type that I've told you about. So let's say a native metric. So I will take the system lag, for instance, and I will filter by job ID, and the one that interests me is this one. Okay, and you can see the system lag here. It's pretty good. 1 second, 5 seconds. It's pretty okay. And we'll have a look later at this more in detail. Let's have a look now at a worker metric. So let's say CPU utilization. So I compute CPU utilization. one. So here there's a lot. I will filter by job ID again. I will use the one that is processing. And here you can see the CPU utilization of my different workers. So at the beginning, it was about 20%. Here it's a little bit more. And when you look at this in the context of your job, you will find it very useful. Then let's have a look at an agent metric. So agent metric, I will type agent memory. Here it's one. And there are lots of them, you can see here that actually you can see the buffered, the cached, the free, the slab, the used. So I will filter by state and I will only have a look at the free one. And here you can see that, it's been changing a little bit. These are all my workers, but you can see that towards the end of the job, pretty much all my workers are about 50% of memory consumed. So it's pretty okay. I still have lots of memory available. And finally, a custom metric. So I've created a custom metric in my Beam code called bad counter. And it counts the number, it's just a counter that increments every time I see a bad message. And a bad message is a message that has less than 1 bar of pressure from the machine. So I could just type bad counter here. And Dataflow job, filter. Here you can see my metric is growing. This is expected because I'm just generating random data. So as the time grows, the number of bad messages are just increasing. Okay, so as I said, you can alert on this. You can create dashboards. So I created one here for today, and we will get back to it a little bit later. For now, let me get back to the job metrics tab. Okay, so this is the most important place that you'll have to go to understand your job. So before we get into the details of this job, let me just explain a little bit what the different metrics are. So the data freshness is basically, is your data old? So for instance, let's have a look at here. Here, I see that my data freshness is 2 minutes. It means that I'm trying to read from PubSub as fast as I can, but my pipeline at this moment is not able to read all the messages as they come. And so they start piling up. And so some of the data becomes old. And basically, this is the maximum. The data that is the oldest is 2.13 minutes old. So this is pretty bad when it goes up, and it's pretty good when it goes down. System latency is basically if your pipeline is fast or not fast. It's the maximum time that a message spends in your pipeline. So here, if I look, it's pretty good, 4 seconds. Sometimes you can see that it's going up. We will have a look. Here you can see the auto scaling. So if you've enabled auto scaling, Dataflow will auto-scale for you, so downscale or upscale based on the number of messages that you have, the CPU utilization that is happening. And here you have the throughput. So this is the number of messages that go through your transforms. So for instance, here I can see that I have about 80,000 elements per second going through my pipeline. And then the CPU utilization, really useful. So here I see that there's only one curve, which means that I have one worker and it's very utilized. But there I have two, and depending on the moment, I have more or less. This is very useful because if you see that some workers are very utilized and some workers are not very utilized, it will mean that you have a hot key problem. It means that you have a key that have more elements than other keys. And so it goes to one worker. It means that most of your data is actually processed on one worker only. And this is quite bad. It means that your job is not very well parallelized. And in this case, you might want to add a reshuffle phase, for instance, in between some of your steps. Okay, since I'm using PubSub, I also have metrics about how I'm reading to PubSub, the request per second that my job is doing, and how I'm writing to PubSub. Okay, maybe let's have a little look. I will zoom a little bit at the beginning here. So at the very beginning, my data freshness is 100 seconds because my other job has been generating some messages for about 1 minute. And so the messages have been piling up. Okay? And so this is pretty good. Data freshness goes down to about 15 seconds. My latency is quite low, 1 second. And here you see that Dataflow decides to downscale. It goes from 2 to 1 worker. So why did that happen? So basically, it's related to the number of messages that are waiting to be processed. So here, the data freshness is pretty good. And if you go down to your CPU utilization, they're not very utilized. So we're good in terms of data freshness, and we're not very utilized. So Dataflow chose to downscale. And you see that every time you downscale here, you're going to have a little bump in data freshness and in system latency usually, because you have fewer workers. So Dataflow will have to reshuffle the data around. So in this case, it will send the data to the first worker. And here we can see that we go down to a nice time of freshness and latency. So it means that really 1 worker was probably enough. I had 2 workers here because I chose when I started my job that I wanted to have 2 initial workers. Okay, I'll click here to reset the zoom. And let's have a look at another moment. Here we see that there's quite a lot of upscaling and there's quite a lot of data freshness going up. So let's have a look, maybe from here. So you can see that data freshness goes down, but here is going up. So let's zoom. Let's zoom here. It's going up. It starts going up already, and even after auto-scaling, it's still going up. And so the question here is, why is it going up? And the answer usually is, maybe I have just more data coming into my pipeline. So one way of seeing that, as I explained before, is to look at the throughput of one of your first P collections. So in my case, I will select the reading from PubSub here. And let's look. So before, I'm about 132,000 messages per second. And then here, I'm about 150 or something. It depends. So there's been like a 20% increase. It's not very clear here. I will show you how you can make it even clearer. But you can see that there's clearly a difference in throughput, and this is why your job is scaling. Actually, if I go and look, the thing is, like, if you look at this, the throughput here, you don't necessarily have exactly the number of elements that are coming in. You have the number of elements that are consumed by your pipeline. But what PubSub will do is that it will not back pressure. It will only consume what it thinks it can process. So sometimes it's not that clear looking at this. But I'm lucky because I have cloud monitoring, and I have access to the PubSub topic. And so I have a metric that enables me to see the number of messages that have been pushed to the PubSub topic. And here you can see on the bottom right that it's much, much clearer. There's been an increase in the number of messages posted to PubSub, a very big increase. And this is why my pipeline started to have more worse, let's say, data freshness. And now that I'm here, I can show you some of the things that you will not find on the Dataflow UI directly, but you can find here. For instance, the data freshness per stage can be interesting. So here I can see that I have 3 stages in my job, and I will show you how I know it, but I know that F12 is my first step, F11 is my second one, and F10 is my third one. And you see that the curves are pretty close together. And this really means that the lateness that you get is due to your first stage. And the next two stages, they're not really adding to your data, to your lateness. So if you wanted to optimize something, you might want to optimize the first stage. So to finish, let me go back. And now that we've seen the job metrics, I'll go back to the job graph here. And you can have actually more information about each step. So if you look here, for instance, you can see the throughput. And you can see that the throughput is 79 or 80,000, and the throughput next is the same. But if you had, for example, a throughput that is something, and then you have a throughput that is divided by 2 just after that, it should tell you, the throughput is really going down. There's something. Unless I'm really filtering lots of elements in my job, which can be okay. But if I'm not filtering elements and my throughput is going down, it means that the step is very slow. And maybe in your step, you're just using an external database, which is very slow, for instance. So this will be quite useful. If you click on one, you can also see the system lag for one step. You can see the wall time. The wall time is the time that is being spent on this step by all the workers and all the threads. And also, so you have the information of the throughput that comes in this transform and the throughput that comes out of this transform. So if you have a big gap between these two, there's a problem. Your step is really too slow. And at the very bottom here, you have here something that is important. You have the stage in which the step belongs. And so maybe, as you know, sometimes Beam or Dataflow will really fuse some of the steps and just run them together. And sometimes you don't want that. For example, if you have a transform that reads few elements and then outputs lots of elements, in this case, you might not want to fuse because you're going to have all your elements being processed by only one worker. So you might want to add a reshuffle phase, for instance. So looking at the metrics and looking at the metrics per steps, and also if you want more information, looking at the metrics in cloud monitoring gives you really a lot of information and will give you ideas on what's going wrong and how you can optimize it. And so it's good for investigating your pipelines, and it's also good for being alerted if something is going wrong. So very important stuff, and I hope this has given you some insight about what metrics you can use to understand your job. And back to you.
Thank you, Jeremy. So I think we have a couple of minutes for Q&A. I do not see any questions at the moment on Slack or in YouTube. But because we have that time difference, it might take a couple of seconds to have those questions populate. And in the meantime, do you have any recommendations? Here we go, Q&A time. Let's see if we get anything. Do you have any recommendations for people who want to learn more? Where are you pointing people at?
So basically there's quite a bit of documentation on this. So you would type things on Google like Dataflow metrics, Dataflow monitoring, or you could use one of the names of the metrics, right? Dataflow system lag, Dataflow freshness. And maybe I'll do a little bit of advertising for myself. I've also written a blog post recently that you will find on Medium. If you're interested, you'll just type Dataflow monitoring, and you basically see what I presented here in this session.
Oh, that's great. Okay. While we wait to see if any more questions pop in, you made me think of a really good joke that I learned when I was doing my coding bootcamp. What's the difference between a junior developer and a senior developer?
Don't know.
The difference is that the senior developer has Googled everything and the junior developer has yet to Google everything.
All right. Pretty accurate. Yeah, that's true.
No, I am not seeing any questions.
So yeah, so
pop up.
if you guys or you girls want to, if anybody in the chat or looking at this wants to ask a question on the Slack or on YouTube, I'll be happy to take them later.
Thanks, Jeremy. Well, that's all the time we have for this session on monitoring with Jeremy Gomez. If you have any questions, please shoot them off on the Slack, and stay tuned for our next session. Take care.
Thank you.
Thank you, Jeremy.
Thank you.
Hello, welcome to our third talk of the day of Beam College. And our next talk will be about how to do logging in Dataflow. And we have with us Meran Nasir. It's a pleasure to have you, Meran. Meran
Thank you, Pedro.
is a product manager at Google, specialized on Dataflow. And as I mentioned, he will be talking to us about logging. So please carry on, Meran.
Thank you for the introduction, Pedro. As you mentioned, my name is Maran Nazir. I am a product manager with Dataflow. And today I'll be talking to you a little bit about the logging stack. So every SRE best practice book will tell you how important it is to have logging and error reporting capabilities for your cloud-based applications. And Google Cloud offers an end-to-end suite of tools called the Operations Suite. That includes cloud monitoring, which you've just gone over with Jeremy. We have cloud logging, error reporting, profiler, trace, debugger, and several more. And the ones we're going to be focusing on in this session is really around logging and error reporting. And this begs the question, well, what do I need to do to enable these for my data flow, my data processing applications? Simple answer is nothing at all. Dataflow offers native integrations with cloud logging and error reporting that makes some of these critical parts of making your data processing application reliable very easy to do. So the way we'll kind of structure this presentation is do a quick walkthrough just via screenshots and talk about a few of the conceptual takeaways from each of these things, each of these screens, as well as kind of cover some of the best practices that we've seen in the field. And then we'll jump into a 10 to 15 minute demo. First, let's talk about data flow logging. You'll find the data flow logging panel at the bottom of your job details page. You'll see in the screenshot here, in the bottom right of the corner, there's a little arrow that you can click on that expands the logging panel. And when you see the logging panel, you'll see three different screens. You'll see, or three different panels. You'll see one for job logs, worker logs, and a diagnostics tab. Just to kind of refresh your memory on what these respective things are. Job logs are messages that report the status of the job as a whole. Again, this will also reflect any kind of errors that are happening on the workers that'll get propagated to the job, but also kind of reflects kind of the orchestration of workers and some of the messages that the data flow service is propagating to your job. Worker logs are messages that are produced by the worker instances. Again, as we talked about earlier today in the architecture section, workers are basically the instances that are processing all of your do functions and your actual Beam code. And so any errors that are, or any kind of logs that are printed from them will be propagated through the worker logs tab. And then lastly, a diagnostics tab that will show you the frequency of each error across your jobs. And we'll dive a little bit deeper into that error reporting and how that expands into our overall error reporting integration. So let's take a closer look at the logging panel. Again, we'll dive a little deeper in this when we go into the actual demo. But you have a logging panel that allows you for some basic functionality. One, allows you to filter for a minimum severity. So if you're only looking for, let's say, debug, warning, or error logs, you can simply click on that filter button to kind of quickly rifle through all the kind of things you need to look for in your logs. You can also search for specific strings. So if you're interested in a specific type of log, you could quickly do that within the interface provided within the data flow monitoring UI. So, why don't we take a look at a few of the common errors and logs that we see that usually point to a symptom of your job falling behind or an issue being in your data flow job. If you have an initialization failure where we aren't able to essentially read your jar file, you might see that in a worker jar file misconfiguration log. If you have memory pressure, this is a very common thing we see with customers' pipelines. From pipelines that are undersized and don't have enough enough memory to actually process the code. You might see an out of memory error. Or you might also see a VM being shut down due to garbage collection thrashing. You also might see a very common problem in data processing from slow processing. This might mean a lengthy operation in a particular step. This could mean a hotkey that's detected. But again, these are searchable within the logging UI. If you have a specific record that is too large for our data flow backends or our worker to actually process, you might also see a commit key request that exceeds the size limit. In which case you might want to maybe shard that data in some way or process it in a different way if it's an overloaded key. And then lastly, if you have too much logging, you might also see a throttling logger worker. We do have a limit to logging. I believe it is about 15,000 logs per 30 seconds, if I recall correctly. You can reference that in the documentation. But you might also get a log message for having too much logging. But the logging panel in the Dataflow UI isn't the extent of what the Dataflow logging UI offers. It also allows for going into the Log Explorer's UI. So you'll see a little expansion arrow in the logging panel, and that'll take you to the Logging Explorer screen. This is kind of the part of the cloud logging or the operations suite of tools in Google Cloud. And you'll see, a lot of important functionality in it, but I'll highlight a few things in this particular screen. One, you can create custom queries for your logs. So if you want to identify specific, logs that are interesting or with a certain severity level from a particular step, you can basically kind of build your query in the query, the query preview tool at the top. You can also see a histogram of specific, logs, which kind of makes it very powerful to see if you're looking for a specific type of log, how often it's occurring on your Dataflow processing. And then lastly, we have a helpful bar on the left side that allows you to filter for different types of logs. You'll see a list of different types of log names, which we'll talk about here. We have it. We print out Dataflow jobs. Do print out a different types of logs. As I already mentioned, job message logs are ones that are various components of the Dataflow service are going to be propagating. So if we are changing the auto scaling configuration, changing the number of workers or shutting down workers, we're showing progress on job steps. You'll see that kind of show up in the job messages, filter. You'll also see worker logs, which are produced by Dataflow workers themselves. They are doing most of the pipeline work, including processing your actual Beam code. So if you see, user exceptions or, errors of your due to your code, you usually find them in the worker filter. You'll also see a few logs on worker startup. This is capturing messages that are related to the actual startup process. So, if you are, if your job is having problems downloading jars from cloud storage or some of the dependencies that are associated with your job, you might see the logs there as a starting point to look at. Shuffler will include messages from workers that consolidate the results of, parallel pipeline operations. And then lastly, Docker and Kubelet are, some of the messages related to the processes by the Dataflow service that are occurring on the machine itself. And you also have the ability to write your own custom logs. So you also should write custom logs for specific events that are interesting to you. In Java, we provide the SLF4J simple logging interface facade for Java library that is provided out of the box for Beam. We also contain support for a few other libraries that I'll ask you to look at the documentation for. Python also includes the logging library package. All you need to do is an import statement to kind of enable that. So, let's take a quick look at a code example that we'll go back into our demo. We are similar to Jeremy's demo. We are looking at a job that is ingesting, meter data, the energy meter data, and measuring pressure from gauges, across multiple factories. What I want to be able to do is if I see a gauge that is showing a negative value for a pressure, which is probably off, there could be something wrong with the instrumentation or something wrong with the way that was particularly measured. In which case, we want to be able to log that as a warning and be able to kind of specify that. So as you can see in this piece of code here, I've created basically a specific statement in my code that shows that if the data value is showing up as less than 0, I'm going to log a warning statement that shows a negative pressure value and also propagates that specific negative value. When you want to look for custom logs and using that query builder in Logs Explorer, you can use essentially create the resource type, filter for resource type Dataflow step. And a log name that's similar to the statement right here. Okay, so now we'll move on to Dataflow error reporting. If you remember, you'll see when we log on to the Dataflow job details page, you'll see 3 different tabs. You'll see the job logs, worker logs, and you'll see the diagnostics tab. The diagnostics tab is helpful to show where errors occurred along the chosen timeline. It'll show a count of all those logs that are all those errors that were logged. And in some scenarios, you'll see possible recommendations for your pipelines. So maybe a quick kind of a deep dive on this specific piece. This is a relatively new feature, but we have just launched log-based recommendations for logs that show very clear calls to action. We will provide a kind of semantic information around what you can do with those specific errors. So what you'll see here in this example is an operation that's running a little long, and you'll see that the code as it kind of deciphers that message. You'll also see shutting down the JVM after 8 consecutive periods of garbage collection thrashing. That's normally a memory pressure issue, and so when you say that the worker is shut down, when you click on that error, you'll actually now get to the error reporting page, which will link to helpful documentation, a knowledge base article on debugging out-of-memory conditions. So when I click on a specific error, I'll actually get shown the error reporting interface. So this again is another service provided through our operations suite. Some of the salient things to look at in this particular interface, you'll see a histogram that's showing the errors across your entire Dataflow project. You could filter for a specific job, but if you want to, if you have a number of different jobs that are running very similar workloads, it'll help you identify potentially across the entire fleet of pipelines by searching across your project. You can also select different time ranges from the last hour to the last 6 hours, last day, as well as examine full stack traces for these respective jobs, so you can see where exactly in your code might be wrong. And then you'll see on the left side here, you'll see a link to issue. If your organization has its own issue tracking software, like whether it be Jira or some other tool like that, you can actually link it to your own issue so that when a specific issue is resolved, you can actually track that also in the error reporting interface. So before we dive into the demo, let's quickly take a quick look at some best practices, some of which have already been mentioned here. So, one of the things that causes a lot of our customers' pipelines to go awry is when a corrupted piece of data causes your entire pipeline to go down. So when a misformed shape of data shows up and causes your processing to basically not necessarily understand how to process that, what we recommend for any job, any use case, is to write it to a dead letter sync. That means writing erroneous records to a dead letter queue, and also using a kind of an exception block that allows you to log an issue and send that raw data as a SOUD output to store that unprocessable data. That allows you to kind of offline analyze what might be wrong with the shape of the data, what kind of condition you might want to consider in your writing your actual own code. So this is a little bit of pseudocode, but let's walk through what each of these things are doing. So we have a pseudocode example that shows an example of a pattern. This pattern written in Java. A few things to note here. So in this first, in that first highlight, you'll see that we wrap that process element function in a try catch block. So we'll try that process that piece of code that processes the element. In the event that it is not able to process that, we are able to basically make a custom log and then basically output that corrupted data to a sink. Inside the catch block, as I already mentioned, we don't log every error. You'll see the optional logging at the debug level. That might overwhelm the entire pipeline. So instead, we send that erroneous record to a dead letter sync so that we can essentially analyze it offline. And then lastly, we use a tuple tag so that we can write to multiple outputs in the resulting P collection. This again allows us to write to downstream P collections that are required for to continue your processing, but also to send raw data to persistent storage like BigQuery Cloud Storage so that we can expect them offline for specifically the erroneous records. This is a pattern that helps you continue your data processing without having to kind of back up all the processing, but also allows you to, again, assess, if there are erroneous records or if there's, a particular condition your code hasn't actually accounted for, how to analyze that. Awesome. So with that, I'll dive into the demo. So give me one moment to share my screen. Awesome. So you should be able to see my screen now. Awesome. So you might already be, familiar with this job, but you'll see this is the job that you might have seen in the press presentation on monitoring. Basically, reading from an event stream that's collecting factory pressure gauge data, and again, quickly identifying, doing some aggregation, some windowing on it, a conversion, filtering bad events, and then computing an average for the readings from those gauges. So, as I already mentioned, when you first go to the event processing job, you'll actually see just this job graph. And to get to the logging panel, you will basically one second. You'll see the bottom here. When the log panel again will show you, job logs, worker logs, and diagnostics. As you can tell, this job is relatively healthy, so we're not going to see any errors here. But worker logs will show specifically, the logs that are being printed from your specific worker nodes. And jobs logs, relatively simple, will show you the logs that are coming from at the job level. Because there aren't any error messages that are propagating from the worker level, you won't see very many messages at this level right here. You'll see kind of the bulk of what you're looking for in your worker logs. Once again, you'll see that if I want to actually click on a specific step, I can actually filter for worker logs for that specific step. So let's say I want to look at this KV conversion. When I see that, I'll see, actually, let me go to filter bad events. I'll see a number of different messages for this specific step. Why that's a powerful tool is if I want to be able to see, when you see a job that's unhealthy, you might see a red exclamation mark with a little badge next to one of these steps, in which that's basically conveying to you that there might be an error in this specific step. So to quickly identify, where the error might be, you can quickly filter for logs from that specific step by clicking on a specific step. Once I am done looking at the specific worker logs, I could basically clear the selection, and now I'm now seeing logs across, all of my workers again. I also have the ability to search for, a minimum severity. So again, by default, you'll see info logs. But you might be just interested in seeing warning logs and above. What you'll see is, again, remember the custom logging that we implemented for negative pressure values? I'll see that I'm seeing all the kind of negative pressure values that have been printed from the factories, as well as the specific factory that propagated that. Why that might be helpful is, if I know that most of my errors are coming from one specific factory, that identifies, where I could potentially, seek to basically support something for my event producers, where there might be some error in the instrumentation or the actual device itself. And then, as also, warning is one of the things I can also look for, but I can also, if I look at info right here, and if I wanted to filter for logs, I can simply click, if I know what my custom log might be printing, I could type in something like negative, and I will find all of the logs that are associated with that specific custom log that I've created. So, now that I've done all of that, why don't we click on to the Logs Explorer? So you'll see, back to this screen, on the right side, a little button that clicks to the Logs Explorer. And what's nifty about this is when I have done this, I will actually see that I have essentially, filtered for this specific log and created a query for that specific log. If I go back to the screen right here and just click to the overall Log Explorer, that allows me to kind of see all my logs and design queries around that. So once again, let's say that I want to look at simply just warning logs. I click on this, and I'll see a histogram of numerous occurrences for those warning logs. So I'll see that I see a spike around, it looks like 9:56 a.m. that shows a number of different warning logs. If I wanted to click on this, I can take a closer look on, where, some of these warnings might be. Again, once I can see that I'll have these negative pressure values that are of interest to me. I'll also see, other things where there's a data leak that's potentially possible. For whatever I decided to kind of basically implement, I could probably identify using this Logs Explorer tool. So now that I've kind of played around with this Logs Explorer tool, how can I actually kind of go one step further with my logs? If you see that, when I look at these negative pressure values, I could see actions right here. When I click on this Actions tab, I'll see I have a couple things I can do here. I could download the logs, or I can create a sink that will basically write these errors to a specific sink. This is similar to what we had discussed in our presentation around writing your errors or writing specific logs of interest to a sink that allows you for future analysis. So one of the things you could do with this potential this analysis is say, okay, so now that I have all these negative pressure values, I can look at which factories are producing the most negative values. That might point to an issue with the devices that are measuring values in my specific factory, or something else to do with the kind of the application itself. I can also create a log-based metric. So when I click on this, you'll see that I have the ability to create a metric based on this on these logs. So for example, if I wanted to count the number of negative pressure values that I'm reading in my pipeline, I could simply create a counter metric that allows me to kind of specify, and then to specify the name, a description, and what you'll see is in the monitoring UI, you'll see those counters actually showing up in your job details page. This allows for a pretty simple way of basically creating a metric that allows you to also then alert on. So in the event that you see, a certain number of errors or warnings, you can quickly respond to them. So you can basically rectify any issues in your producer or in your pipeline itself. So with that, I am. That is everything that I had for the logging presentation. I will take questions from that.
Thank you, Meran. Let's see what we have. Give us a second. We've asked in the YouTube to see if we have any questions, and we are also monitoring the Slack. If you have any questions, please post them either in the Slack or the YouTube chat. And remember, everybody, that the materials, the slides that Meran showed are available in the GitHub repo. We just updated them a few minutes before starting this talk, in case you want to reference them later. We give us a second, Meran, because we have a question by Jeff McCarroll. He says that in the best practices section, the guidance was to write the error value twice. he didn't quite get the point there.
So good question. We're not suggesting to write the error value twice. We're essentially there's two mechanisms. There's essentially you are writing to a separate sink that allows you to basically continue your data processing, but also to propagate a warning message or your custom log, so that your pipeline and your monitoring infrastructure is actually aware that there is error that's been written. If you do not write the custom log, then you're essentially just writing to a different sink for this, data that hasn't been able to be handled by a processing logic, and by basically creating an optional log that doesn't overwhelm your logging infrastructure, but also a separate sink for you to basically read the information later on. You are essentially kind of covering both of your bases. So it's not exactly writing it twice. Essentially, kind of it's depositing that data in two different areas so that you can essentially handle that data in different ways.
Okay, and yeah, actually he followed up with that, saying like it would be once for debugging and the other one to put it down the stream in the pipeline.
Yes, exactly.
Okay. We had other people that were writing in where we saw that they were typing in the Slack, but they haven't committed their comments. So I don't know if it was thank yous or questions, but they repented. So we are on time. We need to go to the next session, which will actually be troubleshooting and debugging. So will you be around the Slack? Could you check the Slack later, Maran, so that we can... there's a quick question by Moses asking if there are any extra costs in data flow logging.
Yeah, quick question. It's not. For custom logs, I believe you would be charged, but for the native logs, you are not. It does not count towards your logging. Your free logging.
Okay.
And so this is a common misconception. Customers disable their logs thinking that they are going to be charged for them, but data flow logs are actually are contained as part of the cost of doing business. So it's not. It does not go towards a cost.
Great.
Good question, though.
Okay. So having said that, thank you so much, Maran, and we'll continue in our next session in a minute or so. Please stay there, and we will continue. Thank you, Maran. And
Thank you,
bye,
Pedro.
everybody.
Hi, welcome back to Beam College. My name is Alma, and I will be moderating this session, which is troubleshooting and debugging with our teacher, Chirag. I'd like to remind everybody to please fill out the survey and feedback form that you can find on the Slack channel and here on YouTube. Our teacher, Chirag, is a data analytics and system engineer on the Google Cloud Platform. And when Chirag isn't working, he can be found mountain biking or going on hikes with his dog. So Chirag, let's learn more about debugging and troubleshooting. Take it away.
Thanks, Alma, for the introduction. I'm Chirag, and today we'll be learning more about troubleshooting and debugging with Beam using the Dataflow Runner. So for the agenda today, we'll be looking at the troubleshooting workflow and the different types of troubles you can run into when deploying your Beam pipeline on Dataflow. The general troubleshooting workflow involves two steps: checking for errors and looking for anomalies in the Job Metrics tab. So we're going to focus on the first. This involves looking at logs and taking a closer look at the execution graph. When you submit your Beam pipeline to Dataflow, it gives you a list of all the jobs that are currently running or succeeded, and it lets you know the type and time and all the other metrics about the jobs. This is generally the first place you want to check if there's a pipeline that's not working out as expected. You can see here that if the job is in a fail state, we can click on the job and dive deeper into the root cause. It's also important to note that not all problematic jobs will be in a failed state. So batch jobs will fail. Batch jobs will fail after 4 retries, while a streaming job will fail after an infinite number of retries. So sometimes, more often for streaming jobs, if there is a error that happens further down in the pipeline, it'll still say it's running, but it may not be working as intended. So after we click on the failed Dataflow job, we can check for the errors. It will show us the errors up top here on the header of the job, and we're also able to find the step in which it failed in. Oops, went too fast here. Okay. At the bottom, there's a log section, which gives you more detailed error messages, and that can be further expanded by clicking on the little arrow button. This takes you into Stackdriver. Stackdriver is our log monitoring, so all the logs that happen in your Dataflow job come in here, and you can look through it in Stackdriver. So there are many different logs that can be used to help look into jobs. Sometimes the lack of logs can be a good indicator of where the issue might be as well. So, for example, we have job message, worker startup, shuffler, and Docker and kubelet logs. So if you don't see worker logs, but you see worker startup logs, that might be a good indication that the workers weren't able to start up, and that you should look into the worker startup logs a little bit closer. The job message log, just stepping into it a little bit more into what each of them mean, is the job message logs, those contain your job level messages and the various components that Dataflow generates. Your worker logs contain messages logged by your code and Dataflow. So if you're using any of the logging libraries to log anything in your Pardue function, or you're logging any external calls you make, this will all show up under your worker logs. Your worker startup logs are present on most Dataflow jobs and capture messages related to the startup process. So downloading your dependencies, installing your dependencies, and so forth. The Shuffler logs are the logs that contain messages from your workers that consolidate the results of all the parallel pipeline operations. So if you're using like shuffle steps such as group by or Pardue functions. Docker and kubelet logs are the logs logs that are related to public technologies which are used in Dataflow workers. So each Dataflow worker does run multiple containers for different purposes. So after checking error messages in the logs, the next part is looking for anomalies in the job metrics tab. And so what do I mean by that? When you so these metrics here are more specific to the Dataflow runner and not necessarily specific to your Beam pipeline. But when you submit Beam to the Dataflow service, you get a few metrics here. One of them is the data freshness metric, and data freshness and next one, system latency, are good indicators of performance for streaming jobs. So the data freshness tells us how old our backlog is, more or less. That's how you can think of it. So you can see between the hours of 9 p.m. to 3 a.m. here, our backlog our data freshness was very low, which means that we were able to digest a lot of that data, or at least your Beam pipeline was able to digest a lot of that data and act a lot of those messages, or move it downstream. The increase in data freshness, however, tells us that there were more messages sitting in our backlog than being ingested into our Dataflow service. So this tells us that there might be a problem with ingesting a lot of messages. Now, another metric is system latency. So while data freshness deals with the oldest piece of data sitting in your backlog, the system latency deals with the oldest piece of data going between the different stages in your Beam pipeline. So they're kind of the same, but they're very different in terms of telling us different things. For example, in this example, the system latency is very low, below 5 seconds, but our data freshness is really high, around 200 minutes, which tells us that our pipeline is able to move the data between all the different stages of the pipeline. But with the data freshness increasing, we can see that we're not able to achieve we're not able to keep up with the throughput in our backlog. So if we see system latency and data freshness go up at the same time, that's usually an indication that our pipeline is struggling. There is code in the pipeline that is struggling to keep up with the backlog. So more anomalies to look out for. So for all Dataflow jobs, the CPU utilization graph is a great indicator for the parallelism in a job. And it can also indicate if a job is CPU bound, if all the workers are sitting up at 100% CPU utilization. The latter half of the CPU graph shows a good example of limited parallelism. So the limited parallelism here is that we have many workers sitting below 20% CPU utilization, but then we have one worker sitting up near 100% CPU utilization. This is a good indication of a hotkey. So when we take in work in a pipeline, each worker is assigned a key range, and that ensures that each worker gets all the work for that key, and that it's not, the same data related to that key isn't given to other workers. If there's a key that's too big, we get hotspotting, and we can see that through looking at the CPU utilization graph for cases like this. So now let's talk about the different types of troubles we might encounter. So there are 4 main types: failure building the pipeline, failure starting the pipeline on Dataflow, failure during pipeline execution, and performance problems. So let's first start looking at the failure building the pipeline. So these errors are generally attributed to compilation errors in Beam. So while Apache Beam is building your data flow pipeline, validating the Beam aspects as well as your input and output specifications of your pipeline. So these errors specifically can typically be reproduced using the direct runner. So instead of using the data flow runner, we can use direct runner and test against some unit tests. Just keep in mind though that no job will be created on the data flow service if there's an error while building the pipeline, building your Beam pipeline. So here's one example of that. So the example here depicts an error where the pipeline is performing an illegal operation that is checked and caught while building the code on the Beam side. So this message would be presented to you if you were in your terminal, if you were to use direct runner. You can submit it to the data flow service, and it will also show a similar error, but there won't be any pipeline or any execution of any kind on the service. So the next type of trouble is the failure starting the pipeline on data flow. So once the data flow service has received your pipeline graph and your Beam model is compiled and can be executed, the service will attempt to validate your job. For example, are your PubSub subscriptions valid? Is your path right? Is your Google Cloud Storage bucket accessible? Is it created? And it'll also check permission issues. So does your Surface account have the permissions to access different parts of all the services you're using in Dataflow? Yeah, so checks for permissions and checks for access to different files. So if your job fails the validation process, you will see an error message in the Dataflow logging, as well as your console or your terminal, because it is blocking execution. And in a situation like this as well, no Dataflow job will be created from your Beam pipeline if the Surface account doesn't have any permissions or can't access anything else. So this error here is an example of pipeline code which passed its validation, but was rejected by Dataflow due to the lack of permissions in the project. And we can see that it wasn't able to create the project, but it was able to, it passed all the other validations. So permissions, however, cannot be tested on direct runner. Permission issues can only be tested in the Dataflow service itself, just to note. So the next two types of troubles, failure during pipeline execution and performance problems, are probably the two most common types of issues that I've encountered. So we can start by taking a look here. So while your job is running, you may encounter errors in your worker code. These errors generally mean that your do-offends in your pipeline code have generated unhandled exceptions, which result in failed tasks in your job. Exceptions in your user code are reported in the Dataflow monitoring interface, as we can see here. And like mentioned earlier, we can actually step into this a little bit more. And when we look at the stack trace, we can see that it's coming from the org Apache Beam user code exception. So how do we limit that, or how do we prevent that from becoming an issue, or I guess stopping the pipeline? We can add to do that, we can add try-catch blocks in our do-offend. So in the process method that goes through all the elements, we add a try-catch block. And if there is an issue processing an element, we can handle that exception, and we can choose to log that and then also tag that element. In our par_do, we can actually have two separate outputs. And so if we tag the good elements that didn't cause an exception, we can tag that as good messages. We can have that go, and continue the normal processing downstream. But if there's a message that causes an exception, or is something that we don't want to go down that path, we can throw the exception, catch it, and then tag it as a bad message. And we can actually return 2 separate outputs from our Pardue. And we can this will allow us to handle our bad messages more appropriately, whether it's writing to a dead letter topic in PubSub or writing to a dead letter table in BigQuery. So we can track this, like I said, by using the logging libraries for Java or for Python, and it'll show up in Stackdriver. This will allow us to see the specific elements that cause exceptions. We can also, in the logs, like mentioned earlier, we can check the worker logs or worker startup logs for any errors. And then we can set our Pardue to write the failing elements to an additional output. So anything for dead letter, so dead letter topics or dead letter tables in BigQuery. This will allow us to inspect that later on. So batch pipelines can only be retried. A work item can only be retried up to 4 times, whereas a streaming pipeline can stall indefinitely retrying a certain piece of work. And so the job will fail in a batch pipeline, and that should be visible, more easily visible in your Dataflow console. But in streaming pipelines, because it's going to be stalling indefinitely, it's going to still show a running status in the console. So you can always set monitoring alerts as well and check for high data freshness. You can look at job logs, system latency, cloud monitoring, and any other metrics. So for example, if your streaming data pipeline is reading from PubSub, and you can set a monitoring alert on the oldest unacked message or act expirations on your PubSub topic or subscription. And that'll let you know, hey, there's a problem reading from my topic or reading from my subscription. Okay, what are my pipelines reading from that? And then you can go and check your pipelines to make sure that there's nothing that's not working as intended. So another type of trouble is performance issues. A few things that impact the performance issues are pipeline design, data shape, and interaction with sources and sinks through external systems. So pipeline design, that really refers more to how many steps are actually fused together, right? So if you read from, for example, if you read from PubSub, PubSub automatically has 1024 keys when you read from it, and anything fused to that step will contain 1024 keys. I guess going further down. So that could cause issues depending on whether you need fewer keys or even more keys later down in your pipeline. Data shape refers more to skews in your data. So do we see, do you have one key that has way more data than the other? And the other one is interactions with sources, sinks, and external systems. So are you using your sinks and sources appropriately? For example, if you're writing to a relational database, and let's say you're using something like Python, and Python doesn't have a relational database IO connector for it just yet. So you use a third-party connector to write to the relational database. Things like opening up a new SQL Alchemy database connection pool every single time you want to create a connection would slow down your pipeline immensely. So the user interface provides a lot of useful information to debug performance at a step level. The step info section can provide useful information, including wall time. Oh, oops, I set the wrong thing here. Yeah, wall time, input elements and input bytes. So how many elements are being added to that step in your Beam pipeline, and then also your output elements and output bytes. So going back, the wall time for a step provides the total approximate time spent across all threads in all the workers doing the initialization for that step, the processing the data, shuffling the data, and ending the step. The input element count is the approximate number of elements that the step received, and the output element count is the number of elements processed by the step. Oops, let me go back. So just to take a look here. So here's the data flow console. I've submitted a few Beam jobs here. We can see that this one failed. And if we step into that, we can see that it also didn't start anything. And the reason for that is, step into the logs to look more, was because I didn't create a GCS bucket for it. Now, this kind of issue you would be able to find using Direct Runner, but something like permissions you wouldn't be able to. Now, if we go back, we can see that this is canceled. Now, this one here did succeed, but if we look into what happened, we can see another anomaly here. We can see that one of the pipelines, or one of the workers in our pipeline, stayed at 100% CPU utilization, while the other workers were near approximately 2.5%, which shows us that there might have been a skew in data. But another way we can also confirm that is by looking at the wall times here, and by looking at the input and output collections. So we can see that our input was 100,000 and our output was about 2. This is another indication that okay, so there are about 2 keys and about 100 million elements, which points to some, and I guess this worker over here was overloaded as well. So that, in conjunction with, if we go and look at the worker logs, was operation ongoing for over 737 seconds in our shuffle step, shows that we have a skew in our data when reading that in. And that's another hotkey issue. We can come back to our read step from BigQuery, and we can see that for version 1, we added 100 million, but for version 2, we added 1,000. So it's clear that our data skew had to do with our one key having significantly more data in it. And yeah, so thank you all for your time. And if you guys have any questions, I'd be happy to answer them.
Thanks, Chirag. I am not seeing any questions yet popping up on YouTube. I don't think this has to do with.
I think I see something in Slack.
Yeah, something about logging. Is that? So it says these questions about data flow logging. Is there any extra cost in data flow logging? Is this something relevant to your talk, or it might be a question for a past?
Yeah, I think that one was for the previous presentation.
Okay.
Yeah.
Okay.
I'm not too sure about that, but that should be on our public docs. Actually, I'm pretty sure that's specified on our public docs.
Okay.
And I can try to answer Jeff's question. He said once for best practices, the guidance was to write the error values twice, once for debugging and again downstream in the pipeline. Yeah, so you could handle it either way. You could output it to your logs, or you could have it write it to a dead letter table in BigQuery, or write it to a dead letter topic in PubSub and inspect it then. Or you could do a combination of both. I think the next question was, I've sometimes found this kind of logs in this pipeline about the operation ongoing without outputting. What could this log mean? No operations completed within the last 37 seconds. 1 operations in progress. Yeah, so when a Dataflow pipeline, or when you submit your Beam pipeline to Dataflow, it does fusion optimization for all your other steps, so that it optimizes your pipeline execution. Now, sometimes if we have steps A, B, and C, and then in step, let's say step A has step A isn't able to progress, and step A is the one that's emitting the operation ongoing in step for at least 1 hour, 30 minutes. And it'll also be followed by a log, no operations completed within the last 37 seconds. That's because step B and step C are dependent on step A. And if step A is going through some kind of skew, or it's not able to complete its work, maybe because of another dependency issue, that's one reason we'd get that kind of error.
And we have another question from YouTube. Sushil asks, can Cloud Debugger be used to debug team pipeline code?
He said, can Cloud Debugger be used to debug Beam pipeline code?
Yes, that's the question.
I'm not sure about that one. Yeah, I haven't played around too much with Cloud Debugger. What is that? Is that the debugging tool in the console? Yeah, I'm not sure. Not sure about that one.
Sushil, if you're listening, and you can give us a little bit more clarification on your question, drop that into the YouTube chat. This is a question from YouTube chat, from the chat option in YouTube.
Oh yeah, so it does look to, yeah, sorry, okay. I got it confused with something else. It is a feature of the Google Cloud Console, although I'm not too sure. I haven't worked a lot with that to know if I would be able to debug Beam with that.
Okay. And let's see. I'm not seeing any more questions in Slack or any more questions popping up in YouTube. If you have any more questions, you can ask them in Slack. Chirag is there in the general channel. And if you're watching this at some point in the future, you can always drop your comments into YouTube, and hopefully we'll get some answers. Anything else that you might recommend, particularly for people watching this in the future, like great places to get support, more information, where they can learn more, Chirag, about debugging in particular? Yeah.
Well, our public docs are generally a pretty good place to start. If you do ever open up bugs with Google Cloud support, that's another good way to get some help on a lot of your on any questions you may have related to Dataflow or the Dataflow runner. In terms of online material, we try to stay pretty active when answering Stack Overflow questions. So a lot of times you'll see a lot of the Dataflow runner or Apache Beam questions on Stack Overflow are actually answered a lot by a lot of people who work on Apache Beam or if it's about the data flow service, it'll be answered by a lot of people who work on the data flow service. So you can always inspect, you can always verify that if you need to. But there's Coursera. There we have a few tutorials on the console too that might give you some added material if you're just getting started as well.
Great. So that is all the time that we have for today. Please remember to provide us with your feedback. You can access the feedback survey in Slack and in the YouTube chat. And we will be signing off for now. Thank you. Thanks,
Thank you all.
Chirag.
Thank you.
Hello, everybody. Welcome to our last and final session for Beam College, for this iteration of Beam College. Thank you, everybody who has been here, that has been watching the presentations by our instructors. Thank you to our instructors who have been here preparing lots of good content. And for our final session of BIM College, we have Rahul Chandhok, who will actually talk to us about best practices to avoid top user issues. Now, will this be focused? I suppose some things will be focused on data flow, but others are independent of the runner, right?
Yep, that's correct.
Okay. So, well, uh, please, thank you for being with us, Raul, and you can start.
Awesome. Yeah, so hey everyone, welcome to the last session, as Pedro mentioned. So this session is kind of going to summarize all the things that we've seen in our previous sessions today, right? Kind of wrap up how do we, like take all of these troubleshooting best practices and, tools that all of the other sessions presented and kind of summarize them here, right? Again, as Pedro mentioned, we'll be using the Dataflow runner as the runner for this session. So I think without further ado, let's get started. So in today's agenda, we're going to be covering like the first two best practices are mostly around setting up, right? Because one thing with the Dataflow runner is running with Dataflow means that there are a few different things in the cloud that need to be configured to, like have your code ready to run, right? So you want to make sure that these are ready and taken care of. I think in the previous session, we might have spoken about, failing to start the pipeline right after building. These best practices are things that cover that aspect of the failures or that we commonly see. Right. We'll finally wrap up with a couple of common Beam messages, error messages that we see in these Beam pipelines, and what they might indicate and how do we want to, along with like best practices on to avoid them or to mitigate them as you see them. Okay. So starting with permissions, right? When you think about the Dataflow runner, there are three different credentials that determine whether your Beam pipeline can be launched on Dataflow, right? So the first credential is the user role, right? So when you submit a job, right, to Dataflow, right, the role, the IAM role that you have set for your account that is acting as the submitter is what is checked to see if you have the appropriate permissions to submit, right? So for example, if I am submitting a Dataflow job, then this is usually done by like Rahul at myemail.com, right? So we'll start with the user role, and then we'll also talk about the different service accounts, right? So once a Dataflow job is launched, right, it needs to act on its own, right? The Beam pipeline, the Beam code needs to, probably access different read sources to read data, write data again to different sinks. So those are determined by the service accounts, and we'll see that as we proceed in this slide. So with user roles, right, there are three common user roles that are predefined and available for you, right? The first one is the Dataflow viewer role, right? As it says, this is a read-only access to all of the Dataflow related sources, right? So a user with this role cannot launch a job or cancel a job. But if there is a job running and all they want to do is monitor how the job is doing and look at the progression of your Beam pipeline, then the Dataflow viewer is usually a very good role to do this, right? The second role that we have is what we call Dataflow developer, right? So Dataflow developer is a role with more permissions than a viewer, right? You can view the jobs, you can look at the status of the jobs, and you can also update or cancel jobs, right? So if you want to, relaunch or update the existing pipeline, making a difference in like the pipeline options, you can do that via update. Or if you straight out just want to cancel the job, you can do that, right? And the final user role that is there, right, which I see most commonly used by folks who are like actively, like launching the Dataflow jobs is the Dataflow admin, right? So the Dataflow admin has more permissions than the Dataflow developer. And the admin role is required to actually, like create and launch the job, right? You can also do the management tasks like updating or canceling of the job, but admin is the only role which gives you the permissions to actually launch the job. Right? This is because when you do launch a job, right, obviously you submit the job to the Dataflow runner, right? As mentioned in our first session on architecture, we might have touched upon the cloud storage element where, the files, your code is staged, right? So the admin permission takes care that, the code that you have for a Beam pipeline can be staged and made available to the runner, right? And then also, like check that there are enough, check that you have the required like quota, for example, on compute engine to provision the users that to provision the workers that will be running your Beam pipeline. So from the user accounts, we move on to service accounts. So we mentioned 2 service accounts in the previous slides, right? So the first one of them is the Dataflow service account and what we call as the orchestrator, right? So the way the service account usually looks is, like service hyphen your project number at Dataflow service producer, so and so, right? The way I like to think about this service account is in the architecture session earlier today for Dataflow, we might have mentioned the regional endpoint that actually, does the controlling of resources, assigning of work, and really does the management part of your Beam pipeline on Dataflow. So this service account is basically a service account that is controlled by that regional endpoint to do exactly the processes that I mentioned, right? It is the one that checks and provisions the GCE workers for your pipeline, right? If it auto scales, it will provision more workers and does all of that. So you can think about it as, like doing all of the tasks to make sure that your pipeline is up and running, right? It doesn't actually run or read from the source or something. That is not controlled by this pipeline, but it does all of the other process related tasks that is needed, right? In general, this service account has the Dataflow service agent role by default in your project. The recommended step here is to actually not tamper with this service account. It is a Google managed service account, and we recommend that you usually let that service account just be as is so that it can continue launching and provisioning the resources for your job. The next service account, which is called the controller service account, right? This is the service account that is actually assigned to the VMs or workers, and is what does the reading of data, and writing of data in the sinks and all of that work, right? By default, it uses what we call the compute engine default service account, which is there in every Google Cloud project. But you also do have the ability to specify it while launching your job, right? Using pipeline options to use a custom service account or a service account of your own for in place of the controller service account, right? So in that case, the default service account will not be, default compute service account will not be used. And the service account that you actually specify is the one that is going to be, doing the reading of data. So you want to make sure that if you do specify a service account, you give it the appropriate permissions so that it can read your data and similarly write the data to the sink as well, right? At minimum, we also require that the service account that you use also has the Dataflow worker role, which is another predefined role for Dataflow that is available in cloud. So that covered the permissions aspect and the permissions best practices that we have, right? We move on to the networking aspect, right? And one of the big important points to keep in mind with networking is often users, while running Beam pipelines on Dataflow, try to use what we call a shared VPC, right? So this is where your network, where your workers run, is in a separate project, right? This can be due to multiple different reasons, right? Maybe your organization has a separate networking team that manages all your networking resources. So you, as a Beam developer, might not really, be managing that, but more leaving that to the networking team. So in these situations, they may have a network in a different project that they manage and control. But since Dataflow is going to be using this different network, right? We want to make sure that when you do set these, when you do use these permissions, when you do use these network, you have the right permissions set on it, right? So you can use like custom or default networks, right? But one thing to keep in mind is when you are using a shared network in a different project, that your service accounts, right, the data flow service account and controller service account have permissions, right, like the compute network user permission on those networks, so that like the service account can actually like provision use resources on that network for you and actually run the data flow job for you. So this is again one of the key tip or one of the key things to keep in mind when you use like a shared VPC. Another thing is the number of VMs that you can provision is often dependent on the IP block size of the subnetwork that you're using, right? So you want to make sure that the network you use has a large enough IP block so that you can have enough VMs if you need spun up, right? Or your pipeline can auto scale to as many VMs as it needs, right? Or is set by the max number of workers. So this is, again, another key practice, right? So making sure that you have the right permissions and keeping in mind the IP block size of the network is really important here to make sure that your Beam pipeline can run smoothly. One other important point that we like to talk about when it comes to networking especially is configuring internet access. What we mean by this is your workers, right, that run for your Beam job, right? They need to be able to, have the right Beam container image installed on them, right? They need to be able to interact with the regional endpoint that we mentioned, right? So that they can get the required work from the regional endpoint, update the regional endpoint on the progress and things like that, right? So to do all of this, in general, the data flow workers that run your pipeline need to be able to reach the Google Cloud APIs and services, right? So that it can successfully start and execute the code. This is, again, a common mistake that is normally done on the networking side, where a certain firewall rule, for example, or the lack of a networking route to actually let the workers perform this communication can prevent the running of your pipeline and maybe cause pipeline failures, right? So by default, if you do not specify anything, the workers that run your pipelines have public IPs, and if the routes and firewall rules are set up correctly, then they will be able to contact these Google Cloud APIs, the Dataflow backend API, and actually run your job successfully and execute your job. However, if you do choose to, for whatever requirement may be, use workers that only have private IPs, so they do not have a public IP, there is an extra step that you might need to take to ensure that your network that you're using has configured what we call private Google access to ensure that these workers that run your job, even with private IP, can talk to the Google Cloud APIs and services, right? So that's another key point here, is to make sure in general that these workers, whether they're using public or private IPs, have that ability to communicate with the backend services or Google Cloud APIs to execute your data flow job. So moving on, and as for the last point that we have today here on the networking side of things is firewall rules, right? So when you run your Beam pipeline on Dataflow, it uses Google Compute Engine VMs, right? And these are simple VMs which have the custom Beam image installed so that they can run your Beam pipeline. But a thing to keep in mind is, since these are simple VMs, you also want to make sure that restrictions that apply to normal VMs apply to these user data flow workers as well, right? So one of the common issue that we see is, as part of performing the operations or transforms in your Beam pipeline, these worker VMs will actually need to communicate with each other, right? So to do this, the Dataflow VMs have a standard port and protocol that they use, right? So they usually communicate with each other, right? So inter-worker communication normally happens on the TCP port, on the TCP protocol using ports 12345 or 12346, right? So if you are using a custom network and specifying custom firewall rules, and you do want to utilize auto scaling in your pipeline, so you do have multiple workers, then it is recommended that you actually make sure that this requirement is satisfied. That is basically you do have a firewall rule that allows for this specific communication between those workers so that your data can be shuffled between the workers as necessary, right? A common symptom that we see when we might encounter this inter-worker communication issue is an RPC deadline exceeded in cloud logging, right? So as shown in the previous sessions today, the simple way to detect this is go into cloud logging and look at the logs for your data flow job and check for error messages that might look like deadline exceeded while doing worker communication. Like I said, right, if you are not using a custom network, right, if you use the default network that comes in like every GCP project when you create it, that does automatically allow this inter-worker communication. And if you're just continuing to use that default network, there is nothing really that you need to do on your side. But if you do decide to use a custom network or are modifying the network and firewall rules of that default network, then it is important to keep in mind that you do have this required firewall rule, right? So the link that is shown here in the slide should take you directly to and give you like a simple gcloud command that you can run based to ensure or create this firewall rule in your network, right? So that's one of the final important points when it comes to the networking side of Dataflow to keep in mind. Okay, now that we've seen the different permissions and networking issues, we move on to our last section, which is some of the common error messages that we see in Beam pipelines, especially while using the Dataflow runner, right? One of the common error messages that we see, right, which is normally seen, I would say, in batch jobs, and when you look at the reason for failure of a batch job, you could see an error message similar to what is shown in this slide, right? And it says the worker lost contact with the service, right? And you might see this message 4 different times, right? And they could be the workers for each different time could be the same worker or different workers. But what this message usually indicates is that the worker that was performing or doing the work for your Beam pipeline was unable to contact the backend service, right, for Beam and provide updates, right? So if the worker is unable to talk to this backend, then the regional endpoint or the backend is unable to facilitate and execute your job, and normally ends in the failure of your job that we see here, right? This is a common, or most of the times that we see this issue is because if you are running your Beam pipeline and processing a lot of data, but do not have a worker that is able to handle this, right? So let's say a small sized worker or a worker without enough memory, then, if the workers are CPU bound or memory bound, then this is when we see, these are the most common causes of the error message that we see in this slide, right? Moving on, I think that there are some predefined filters, right? Like the one that is currently shown, right? You can use this filter in your cloud logging for your job, and this should help you identify if your job did run into these memory issues, right? So basically, if you did see out of memory exceptions thrown by your workers for your pipeline, right? For if it was not an out of memory but possibly a CPU bound pipeline, then you can try to investigate the CPU usage, right? So in the job metrics that you might have seen in the previous sessions today, you do see the CPU utilization of the workers that are running your pipeline. So you can check and see if your worker is continuously, being throttled at 100, close to 100% CPU utilization. That is normally a sign that, the worker is pushing its limits. So we ideally recommend 70% to 80% CPU utilization. That means your workers are, not being overutilized, not being underutilized, but actually performing optimally. So looking into these different things, right, based on the error message that you see, CPU or memory can help you identify how to, debug this issue and possibly avoid it, right? So, as it says, right, the simple solutions to avoid this issue, right, is maybe use workers that have more memory. So some of the high machines that are provided in GCP, or if it's more of a CPU issue, right, then use larger workers with more vCPUs that can actually process the amount of data that you are doing in your pipeline. So the next and the last error message that we're going to look at here is the processing stuck or operation ongoing in step error message that we see, right? I think this is a pretty common error message that we see in Beam pipelines, right? And honestly, to read through and to look at this message is the simplest way to interpret this is to actually look at what it exactly says, right? What this means is that there has been a single operation, right, within your Beam pipeline that has been running for over X minutes, right? So in the Dataflow runner, I think the Dataflow runner automatically monitors the time an operation takes, right? And if an operation takes a long time, right, maybe 5 minutes or more, that is normally longer than we expect. So you start seeing these error messages in cloud logging for the pipeline. And the general recommendation here is to interpret the stack trace or the traceback for this error message and try to see which part of the code or service is actually throwing this error, right? Not some common occurrences, right? So normally we see this happening for like do functions that you might have as part of your pipeline code, right? Some common best practices that I normally recommend here is if you see this happening for like, an API call that you're making as part of your do function, right? Make sure that you have timeouts and retries with like exponential backoffs included in your do function for those API calls, so that like it is not stuck, right? Or there is no RPC that is just stuck. That is one common recommendation. I would say similarly for some of our IO transforms, right? IO transform should come with like retry settings that you can set as for the IO transforms, and I normally recommend that you do that as well. So this again is a very common error message that we see, right? But it's usually very straightforward in terms of identifying what the issue is and how to actually work on resolving it. And I think if none of the above recommendations, right, help you, then you can always try to use like a profiler or something to understand which part of your code particularly is consuming more time, more resources, and accordingly try to optimize that step. So the final slide that we have for today is just something called like the Dataflow recommender that comes as part of your Dataflow runner for your Beam pipelines, right? And as part of your logs, right, you do have a tab called the diagnostics tab, right? And something that has been included is, if we see error messages that are common, like the ones that I just described previously, like the operation ongoing or, like out of memory issues, then what we try to do is in the diagnostic step, not just show the error message, but also include possible root causes, right? Or the most common root cause, or, like give a better interpretation of those error messages, right? So based on these interpretations and based on the recommendations provided here, you can, perform debugging of your pipeline, right? Maybe use higher memory machines if it's something like out of memory, or, like look into the code if, a certain do function or something is stuck. So with that, I think that's pretty much all we have for the last session today here for Beam College. So once again, thank you all for attending, and thank you all for all of the participation that we've had, and really hope that this has been useful for you. Thank you.
Thank you, Raul. Thank you. And let's see. Let's wait, please, a moment to see if we receive any questions. Let's give it a. We're getting thank yous from Pradeep and from Moises. Remember, this is the last session, so any final questions that you may have, you can take advantage that we have Rahul here, so that you can, any other thing, even if it's not related to Rahul's talk, maybe he can answer any other questions that you may still have. Both we've seen a lot in this couple of weeks, but I'm sure there is still something that you'd like to try or ask. Let's see, we have thank yous from Dan, from Pradeep, from Moises, but I don't think we have any specific questions. So I guess that'll be it. Rahul, thank you. We are, let me see, Pradeep is asking, is there any Slack channel that he can reach in case there's any issues? Well, we will keep this Slack workspace alive for the next few weeks, Pradeep. I understand that I mean, for Apache Beam directly, there's two options. For Apache Beam, there's the Beam channel in the Apache Slack, right? Like that's more for to contact the developers for Beam. But for questions more specific to data flow, what would be the best way to reach you, Rahul, and your team?
So I think in general, my team, like you can try to contact like cloud support. They normally are very useful and helpful for questions that you may have. I think I've seen a few of my team also, maybe monitor Stack Overflow. That's another good source, right? If you have questions, post them. I personally also like Stack Overflow because if others have the same question, then it helps answer multiple. But reaching out to cloud support or Stack Overflow, I think, are some like the most common places to.
Are common places. Okay. Well, and in any case, Pradeep, I mean, we will keep this Slack workspace for at least a couple of weeks. So if you have any questions during that time, please post them here, and we will make sure that reaches somebody in the Beam or the Dataflow teams. Well, thank you, everybody. Thanks for your time and have a great weekend. Thank you to all our instructors who made BIM College possible. For those of you who have not answered the survey, please help us by answering the survey. Let us know what you liked about BIM College, how we could improve it. You can rate the individual sessions. And basically, that's so you can let us know if BIM College was worth it. You know, if you find it useful, if it will help you apply Beam in your company, or if you're already using Beam or Dataflow, if it will help you take that step further. So please help us by answering the survey. We have been posting the link on the YouTube chat, but just in case, I'm posting it again.
I did. There was one thing I wanted to add. I just wanted
Sure.
to say a huge thank you, Pedro, to you and your entire team. I think you guys have really helped in making sure that was smooth, especially I think from the instructor side as well for all of us and for the audiences and making sure that it's easy to access. So thank you as well.
Thanks. I'll extend that to the whole team. Well, thank you, everybody, and have a great weekend. And hopefully, we'll see you possibly in a future iteration of Beam College or some other initiative related to Beam or to open source projects. Thank you. Bye bye. Okay, we're off the air.
Yeah, we're
Nice. Okay, cool.
Okay, Rahul, we'll cut the individual recordings and publish them to the YouTube and let you know. And I guess we'll see with Grace how we can promote each of them and basically to push them in different channels to take advantage of it.
Yeah, I was gonna say that like for some of the error messages that I presented on, I'm like, next time a customer asks me, I'm gonna say, go see my video on it.
Yeah, here it is. Great. Okay, Rahul, have a good
Thank
weekend.
you guys. You
Bye.
too. You too. Stay safe. See you.
Yep. Listo.
listo.
Pues ya estuvo. Ay, ahora tengo que ver unas cosas del hackathon de BBVA. Te dejo.
¿Y eso para cuándo va a ser?
Es en octubre, pero la propuesta hay que entregarla ya la semana que viene.
Oh, ya. Ok.
Dale,
Sale pues.
bye.
Bye.